Hey boys and girls, right now you should be in a quiet place ready for our second flip video classroom. We're on chapter 2, lesson 5. So our essential question for this chapter is, what is equivalence? So that's what you should be thinking about. So today you're going to be learning how to solve multi-step equations, equations with no solutions, and equations with an infinite number of solutions. The steps are to distribute. Then step 2 is combining like terms if you can. Step 3, check to see if you have variables on both sides. And step 4, solve the two-step equation. Alright, example 1. Step 1, see if you can distribute. And we see we have 15 and then in parentheses the 20 plus d. So we're going to distribute the 15 to the 20 and the d. So first we have to do 15 times 20, and you should get 300 plus 15 times d is 15d, and that equals 420. Okay, so now we don't have any like terms. We don't have variables on both sides, so we're going to solve the two-step equation by subtracting 300 from both sides to isolate that variable. When you subtract 300 from 300, it crosses off, and on the left, you're left with 15d equals, and on the right, you have 420 minus 300 is 120. Now again, we want to isolate the variable. So right now, it's 15 times d. So the opposite of multiplying by 15 is dividing by 15. Remember, what we do to one side, we have to do to the other. So 15 divided by 15 is 1, so we're left with 1d equals 8, because 120 divided by 15 is 8. Alright, our next example. Again, we're going to distribute first. 2 times 10 and 2 times t. So 2 times 10 is 20, plus 2 times t is 2t, and that equals 42. Okay, we're going to skip step 2 and step 3. We're going to go to step 4 and solve the two-step equation. We're going to subtract 20 from both sides. 20 minus 20 is 0, so it crosses off, and you're left with 2t equals 42 minus 20 is 22. Now we have a one-step equation. It's 2 times t, so we're going to divide by 2 to get t by itself. Because 2 divided by 2 is 1, we're left with 1t, or just t, equals 11. Okay, example A. Step 1, we can distribute, so we're going to distribute the negative 3 to the 9 and the x. So we have negative 27 minus 3x equals 33. So step 2, we don't have any like terms. Step 3, we don't have variables on both sides, so we're going to go to step 4. Right now we have a negative 27 that we want to bring over, so we're going to add 27 to both sides. Because on the left, negative 27 plus 27 is 0, so it crosses off, and you're left with a negative 3x equals 33 plus 27 is 60. Now we have a one-step equation. We have to get x by itself, so we're going to divide by negative 3. Okay, on the left, the negative 3's cross off. You're left with x equals 60 divided by negative 3 is negative 20. Okay, now example B. Step 1, distribute. We're going to distribute the 5 to the a and to the 7. So we have 5 times a is 5a minus 5 times 7 is 35 equals 25. Again, step 2, no like terms. Step 3, no variables on both sides. So step 4, solve the two-step equation. We're going to add 35 to both sides to get 5a by itself. On the left, 35's cross out. You're left with 5a equals, and on the right, 25 plus 35 is 60. So now we want to divide by 5. Because on the left, 5 over 5 crosses off to 1a, so we're left with a equals 60 divided by 5 is 12. Okay, example 2. All right, we could distribute on the left and on the right here. So first we're going to distribute the 6 to the x and the 3, and then on the right, the 2 to the 3x and the 4. So on the left, we get 6x. Sorry, that's a little sloppy. I'm going to erase that. 6 times x is 6x. Minus 18 plus 10 equals 6x minus 24. Sorry, minus 8. Okay, so step 2, combine like terms. We have like terms on the left. We have a negative 18 and a plus 10. So we have 6x minus 8 equals 6x minus 8. All right, do we have variables on both sides? Yes, we have a 6x on both sides. So we can subtract 6x from both 6x's. Okay. Now on the left, 6x minus 6x crosses off, and on the right, it crosses off. So you're left with negative 8 equals negative 8. Now when you see something like this, when a number equals a number, and this is a true statement, this is when we say we have an infinite number of solutions, because any value that we plug in for x will satisfy this equation and make it balanced. So this is an infinite number of solutions. Again, if at any time I'm going too fast, you could pause, you could rewind, and go back to something. So I'm putting stars around the 6x minus 8 equals 6x minus 8. Because right there you could see they are the same exact thing. That's where you could tell there's an infinite number of solutions. Okay, example 2a. Again, we're going to distribute on the left and on the right. So 3 times 4x is 12x, plus 3 times 8 is 24. So we have 12x plus 24 equals 12x plus 24. So some of you might be noticing something here. If not, step 2, we're going to combine like terms. We have variables on both sides, so we're going to bring them together. So we're going to subtract 12x from both sides, and you're left with 24 equals 24. So when we see that 24 equals 24, we know this is balanced and that there's going to be an infinite number of solutions. All right, whatever number we plug in for x, it will make the equation true and balanced. Again, I'm going to put some stars around the 12x plus 24 equals 12x plus 24. Because right there you can see they're identical expressions. Okay, example 3. Again, we can distribute on the left and on the right. So 8 times 4 is 32 minus 16x equals, and then 4 times 3 is 12, minus 4 times 5x is 20x, and then we're going to add the plus 4x. Step 2, combine like terms. So on the right, we have a negative 20x and a 4x, so we can combine those like terms. Okay, we're back, and when you simplify on the left, there's no like term, so we could rewrite 32 minus 16x equals 12, and then negative 20x plus a 4x is a negative 16x. All right, we have variables on both sides, so we're up to step 3. So negative 16x, we're going to add a 16x to both sides. Okay. So again, our 16s are going to cross off on both sides of the equal sign. And we're left with 32 equals 12. Okay, so this is a little different. Does this look right? Does 32 equal 12? No. So when you get something like this, there is going to be no solution. So whatever number we plug in for x won't make a true or balanced equation. So now we have no solution. And right here, if you see, we have 32 minus 16x and 12 minus 16x. Those aren't true there either. Okay, example 3, we're going to distribute 4 times 5x is 20x, plus 4 times 3 is 12, minus 6x equals 14x plus 21. Okay, step 2, combine like terms. So on the left side, we have a 20x and a negative 6x. So 20x minus 6x gives you 14x plus 12 equals 14x plus 21. So right now you might be noticing something. If not, step 3, there are variables on both sides. So we're going to subtract 14x from both sides. And they're going to cross out on both sides. And you're left with 12 equals 21, which is not a true statement. Those two numbers do not equal each other. So again, there's going to be no solution to this problem. Okay, so if you see 14x plus 12 is never going to equal 14x plus 21. Okay, again, step 1, distribute. So we're going to distribute the 3 to the 6 and to the 4x, and the negative 2 to the 6x and 9. And you get 18 minus 12x equals negative 12x plus 18. You might notice something here. If not, we have variables on both sides, so we're going to add a 12x to both sides. We're going to cross off on the left and on the right, and we're left with 18 equals 18. So now remember, when they do equal each other, this is when we say there's an infinite number of solutions. All right, and then letter D. We're going to start here. You could see 18 and negative 12x, and you have a negative 12x and 18 on the left, so they're identical. All right, in D, when we distribute, we get 6x plus 10 equals 10x minus 20, and we're going to bring down the minus 4x. Step 2, combine like terms. So on the right, we have some like terms, 10x and negative 4x. Okay. The left is going to stay the same, 6x plus 10, and then 10x minus 4x is 6x, and then we have our minus 20. So if you notice here, 6x plus 10 is not the same as 6x minus 20. But we can keep going and subtract 6x from both sides, and we have 10 and negative 20. They do not equal each other, so here we have no solution. All right, 4. At the fair, Hunter bought 3 snacks and 10 ride tickets. Each ride ticket cost $1.50 less than a snack. If he spent a total of $24, what was the cost of each snack? Write an equation to represent the problem. Okay, so we have some variables here. We know that snacks, S could equal the snacks, and the ride tickets were $1.50 less than each snack. So for rides, we could subtract $1.50 from the snacks, because they cost $1.50 less. Okay, so now let's set up the equation. If he bought 3 snacks, that's 3 times the price of the snacks, so 3S plus 10 ride tickets. So we have 10 times, and ride tickets are S minus $1.50 each. And in total, he spent $24. So the 3 snacks plus the 10 ride tickets equals $24. So I'm going to have you guys finish this one at home. I'm just going to start you off. Remember, you want to distribute first. You're going to distribute the 10 to the S and the $1.50. So you're going to bring down the 3S, and it's going to be plus